All right, so in our last video, we learned a different way of writing function equations called function notation. And we learned that function notation hinges on this fact, that these two things are equal. Now, I want to remind you here what these things are. This says a function named f takes an input named x and produces an output named y. So the f was the name of the function, the x inside the parentheses was your input, and the answer that you get is the output. And because these two things are equal, f of x and y, because those are equal, one can replace the other. So if I let, if I let y equal 4x plus 3 be my function rule, my function equation, I can rewrite that by replacing this y with what it's equal to, which is f of x. So I can write this as f of x is equal to 4x plus 3. So the f, remember, was the name. The x was the input. And the 4x plus 3 was my rule that produces my output. So that gave us the option of doing stuff like this. They could say, let f of x, let a function of x equal 4 times x plus 3, find f of negative 2. So what they're saying is, take the function whose name is f and input negative 2 for x. So here's the function whose name is f. When I input negative 2 for x, I get 4 times negative 2 plus 3. I know that 4 times negative 2 is negative 8, and that negative 8 plus 3 is negative 5, so negative 5 would be my output. That would be my answer. Negative 2 as an x value would get connected with negative 5 as a y value in this particular function. So f of negative 2 means take the function whose name is f and replace his x with negative 2. Now, we are going to, again, kind of build on that. Notice we're in this building process right now. And what we're going to do today is talk about, making a mess here. We are going to talk about composition of functions. And if you understand function notation and how it works, this really shouldn't be anything too difficult for you. A composition of functions is nothing more than a way of taking two or more functions and combining them. So let me give you an example. Let's let f of x equal 2x plus 1. So remember, this would be the same thing as y equals 2x plus 1. Okay? And let's let g of x equal 3x minus 5. So I want you to notice that I'm starting out here with two functions. One of them is named f, and his rule is to do 2 times x plus 1. And one of them is named g, And his rule is to do 3 times whatever x is and subtract 5. So they're each telling us how they would find an output. Now, a composition of functions problem is going to look like this. They're going to say something like, find f of g of 2. Find f of g of 2. Now look how I'm reading that. F of g of 2. So notice that I am in this problem using both of the functions. So this is a composition. This is combining 2 functions. Now, here's what you need to understand about this. When we do a composition of functions, you are going to do one thing at a time. Now, here's where you start. You are always going to start with the innermost function in the problem and then work your way out from there. So in this particular problem, the innermost function is g. So to work this problem out, the first thing I'm going to do is g of 2. So I'm going to do that work right over here to the side. So I'm going to do g of 2. Now, I should know what that means. That means to take the function named g, which is the rule 3 times x minus 5, and input 2 where you see x. So take the function rule for g, 3 times x minus 5, and input 2 for his x. So that is going to be 3 times 2 minus 5. And then I'll just do a little order of operations and work that out. So I would multiply first. 3 times 2 is 6. And then 6 minus 5 is 1. So the result for g of 2 is 1. Now, come back over to the original problem with me. This said to do f of g of 2. I just found out that g of 2 is 1. So what that means is I could cross out this g of 2 that I see inside those parentheses because I now know that that's just a 1. So I can replace g of 2 with what it's equal to. I can replace it with 1. So now look what the problem says. The problem says to do now f of 1. F of 1. And again, I should know what that means. That means to take the function rule for f, which is 2 times x plus 1, and replace the x in that function rule with a 1. Input a 1. So this is going to be 2 times 1 plus 1. And again here, just a little order of operations. Multiply first. 2 times 1 is 2. Plus 1 is 3. Now, here's what I need you to understand. If I go back to my original problem, f of 1 is 3. 3 is the answer. So this 1 that you got is not a part of your answer. It was a step you had to do to get there. So this final answer is what we're really interested in, because it's the result of doing f of g of 2, of doing it all. So I want you to notice how this went. I just have to apply one function at a time. And the rule is that I start from the inside of the problem. So I started with that g of 2, and then I worked my way out from there. So this is how a composition will go. Now, I mentioned that a composition can be made up of 2 or more functions. So let's try this. Let's try letting f of x equal 3x, g of x equal x squared plus 5, and h of x equal 2x minus 4. So notice this time I'm giving you 3 functions. And I could say to you then, I want you to find f of h of g of negative 1. So f of h of g of negative 1, and then notice I have to have the same number of parentheses closing up over here that I've opened on this side. So again, this is a composition of functions. It's a little bigger, but we're going to handle this the same way. So you're going to start with the innermost function. The innermost function in this problem is g. So we are going to begin this whole process by doing g of negative 1. So over here, let's do that. G of negative 1. Now we know what that means. That means take the function rule whose name is g, x squared plus 5, and input negative 1 for x in that rule. So we are going to do a negative 1 squared plus 5. The letter tells you which rule to use. The parentheses tell you what to input for x. So we'll do the exponent first. Negative 1 squared. Negative 1 times negative 1 is positive 1 plus 5. So we find out that g of negative 1 is 6. G of negative 1 is 6. So when I come back over here and look at the problem, this g of negative 1 that I have highlighted, I now know what that is. I now know that that is 6. So this becomes f of h of 6. So now again, following the rules, we work inside out. So my innermost function now is the h function. And I can see that this is asking me to do h of 6. So that means take the function rule whose name is h, 2 times x minus 4, and input a 6 for the x. So this is going to be 2 times 6 minus 4. 2 times 6 is 12. 12 minus 4 is 8. So h of 6 is equal to 8. So this h of 6 that I see over here is equal to 8. So notice now that this becomes f of 8. So that's the only thing left for me to do. So I'm going to do f of 8. So I want you to notice that when we get these answers along the way, when we get the 6, we don't just leave that. It becomes a part of the next question. When we get the 8, we don't just leave that. It becomes a part of the next question. So now we're doing f of 8. So we're using the function rule named f, which is 3 times x, and we are inputting an 8 for that x. So this would be 3 times 8, which is 24. And that 24 is the only answer that I really care about. That answer 24 is all I really care about. I want that final answer that is the result of doing all three of those functions. So start with the innermost function and work your way out. Now, one of the things that we need to discuss before we are completely finished with this is we need to talk about order. So let's say you have f of x is equal to 3x minus 1 and g of x equal to 5 plus 4x. And let's say that I ask you to find f of g of negative 3. F of g of negative 3. All right, so we know how this would go. We know that we would take care of this innermost function first. So that means the first thing I'm going to do is g of negative 3. That means take the function rule named g, 5 plus 4 times x, and input negative 3 for x. So we'll have 5 plus 4 times negative 3. We'll multiply 4 times negative 3 first, so this will become 5 minus 12, which is a negative 7. So we now know that this g of negative 3 is the same as negative 7, so we'll make that replacement, and now we'll do f of negative 7. That means take the function rule named f, 3x minus 1, and input negative 7 where you see x. So you're going to have 3 times negative 7 minus 1. 3 times negative 7 is a negative 21. Minus 1 makes a negative 22. Now remember, that answer is the only one I care about. So for f of g of negative 3, the answer is negative 22. So this is my answer. Now, what I want to do here with you is change the order and see if that changes the answer. So instead of f of g of negative 3, let's do g of f of negative 3. So if I wanted to do this problem, I would start with that innermost function, which means that I would do f of negative 3 first. Take the function rule named f, 3x minus 1, and input negative 3 for x. So that's going to be 3 times negative 3 minus 1. 3 times negative 3 gives me negative 9, and a negative 9 minus 1 is a negative 10. So for the f of negative 3 part of this problem, we now know that this is the same thing as negative 10. So we'll finish this problem by doing g of negative 10. Function rule named g, input negative 10 for x, so that's going to make it 5 plus 4 times negative 10, which is 5 minus 40, which is a negative 35. So for this side, negative 35 would be my final answer. Now what I want to point out here is the answers are different. So order matters when you're doing composition of functions. So do the functions in the order that they're written, working from the inside of the problem out. So composition of functions is nothing more than a way to combine multiple functions. And we do that by applying them one after the other. But it's just function notation. The letter tells you the name of the function rule, so you know which rule to use. And the number in the parentheses tells you the input. What do I input for x? Give these a try. We will work on this a little bit more next week. But for today, this is it. Let me know if you have any questions.